Okay, so I think you guys already watched a video on some of this. I'm going to be honest, I don't remember how far that video went, so I just want to do a quick recap. So we're solving projectile motion problems. So we're considering motion that's happening horizontally and vertically at the same time. So important things we need to remember. There's no acceleration in the horizontal direction. We've only got gravity acting downward. When we're solving for horizontal, we're only using our constant velocity equation. So velocity is displacement over time. Okay, so that's going to be our favorite equation for the horizontal. Again, acceleration is always 9.8 down. We'll use our 5 equations of kinematics to work with everything in the vertical direction. Time is the same in the horizontal and vertical columns because it's going to be the same for both directions. So that's going to be our key from figuring out things from one side to the next. We know if we're using the quadratic formula, only positive times work. Remember that velocity is 0 at the max height. And if you're on level ground, you can find the total time of flight and divide it by 2 to get the time to max height. And use that to solve for your maximum height. There's some other steps in here, but especially keep as many decimal places as you can. Right? If you round too much too soon, it's going to very much skew your answers, and we don't want that. If you're stuck, try and solve for other variables. Again, time is always the best one to start with because it's used in both horizontal and vertical calculations. Alright, so we've got 3 different types of projectile motion problems. Today we're going to learn how to solve type 1. So this is when you have a projectile that's launched at an angle it starts on level ground. So level ground means your vertical height, that's what dy is 0 when it hits the ground, right? So it's starting here, it's going up, down, and coming back to the ground. Max height will occur at halfway. Your initial speed is equal to your final speed. So all of those are very important features. Okay, so if you look here, right, this is kind of what's happening in this problem. So you've got your initial velocity, right, which now that we know some things about vectors, right, we can split that into horizontal velocity and vertical velocity. There's very easy equations that will allow us to do that. Okay, so to find your Vx, or your vertical velocity, you will do your initial velocity times cosine of your angle. And to find the vertical, so that's VIY, right? Your initial vertical velocity is your initial times sine theta. Right, so that's how you can split that velocity up into its 2 components, horizontal and vertical. So write those on your note card for your formula sheet, or your formula note card, I should say, because you'll need those when it comes test time. All right, so again, we have our range, right, our horizontal distance, horizontal velocity, and total time. dy, we have our vertical displacement, so how high up. VIY is initial vertical. VFY is final vertical. I know this PowerPoint uses a 2 and a 1, but we like VF and VI. So VFY, VIY. Okay? Right, so that's all for horizontal. We have these for vertical, as well as acceleration being negative 9.8, and t is still time. Remember, time is the same in both. So, using all of that, let's solve our first problem. Alright, so a soccer player kicks a ball on a level field with an initial velocity of 11.3 meters per second at an angle of 35 above the horizontal. Find the time of flight, range, max height, final velocity of the soccer ball. So, Yes, I'm kind of shrinking that down so it's out of my way. So, I like to make a little chart. I have horizontal on one side, vertical on the other. Cool. There we go. So, I like to put all of my information over here. So, horizontal, we're going to have Vx, D, and T. Vertical, we'll have VIY, VFY, A, D, let's do DX and DY, and T. So, right now, all we know is that this ball was kicked at 11.3 meters per second at an angle of 35 degrees. So, we can find those components. So, we use cosine to find x, so that will be 11.3 times cosine of 35. And then to find VIY, it's 11.3 times sine of 35. Also, make sure your calculator is in degrees. Right, so Vx would be 9.26 meters per second. Sorry guys, I'm slow. I'm having to use my phone because I don't have a calculator with me at home. What? Oh, I did cosine again. Hold on. There we go. So that gives you 6.48. Alright, so we also know acceleration is negative 9.8. So we're trying to find the time of flight. So let's find that first. So at that point, so we're finding how long it's in the air. So our vertical height will be 0 because it's going to be on the ground again. So we have dy for time of flight. We're also going to have to find d max. So we'll do that later. But let's find this first. Alright, so let's find our time of flight. Okay, so we get VIT plus 1/2 AT squared. So d is 0. VI is 6.48 T plus 1/2 times negative 9.8 T squared. You guys are ready? We're going to have to do the Pythagorean theorem. Not Pythagorean theorem. Oh my goodness. Quadratic formula. Actually, no, we're not. We can make it a little easier on ourselves and just factor out a T. Set them both equal to 0. So we know that we're getting two answers, right? Because we're talking about the 2 times when it's on the ground. So it starts on the ground, right, at T equals 0. And the other T we're going to find is when we will be at our full time of flight. So we have 0 equals 6.48 minus 4.9 T. Then we'll divide by negative 4.9. And that gives us 1.32 seconds. All right, so we have that for here and here. Okay, so we found our time of flight. Now to find our range, that's dx. Okay, so now we're solving for D, multiply by 1.32. Alright, so our range then is 12.22 meters. Alright, so we found time of flight, we found range. Now we need to find our max height. Okay, so I'm going to, hold on, I'm going to do some moving. Okay, so my D max moved, but that's okay. So to find our max height, we're going to use half of our time. So half of our time is 0.66 seconds. Okay, and now we're going to still use D equals VIT plus 1/2 AT squared. Except this time we know VI is 6.48. T is 0.66. So it's a 0.66 squared. So square the 0.66 on its own. Don't multiply stuff to it first. So 0.66 squared is 0.4356. I'm going to multiply that times 9.8. And times 1/2, which gives us minus 2.1344. And then 6.48 times 0.66 gives me 4.2768. Then I'm going to subtract that. 2.13. Oh, no. iPhone calculators are garbage for physics class, guys. Don't use them. So our max height is 2.14 meters. And BF is just the negative of RVI. And that's it. You solved a projectile motion problem. Okay, so in your packet, there should be a practice problem of a type 1. I want you guys to work on that problem and submit it on LMS under today. Right, so just that one problem. And then tomorrow, we will learn how to do type 2 and move on from there.